Hello, Algebra 2 Honors students, and welcome to a video on functions. I have the definition of what a function is up here on the board. It's a relationship between two variables such that for every value of the independent variable, there is a unique value of the dependent variable. Okay, so it's a mouthful. But what it means generally, if we use x's and y's, for every x value in a relationship, there can only be exactly one y value. So if I say x is 4, you can tell me, yes, y is exactly 7. Or if I say x is -2, y is 5. There's no possible double value for y if there's a unique value for x. Take an example like the number of tickets sold for a players show and the amount of money taken in by players, right? Say tickets cost $5. Well then if they sell 0 tickets, they're not making any money. If they sell 1 ticket, they've made $5, 2 tickets, $10, 3 tickets, $15. This is an example of a linear function. Okay, not all functions are linear, but this is an example of a function because if I tell you x, if I said, okay, x is 7, they sold 7 tickets, you could tell me, okay, they made exactly $35. There's not another possibility. If I said they sold 20 tickets, okay, they made exactly $100. So for every x value, there's exactly one y value. Okay, that's a verbal possibility or verbal example of a function. All right, and here's a visual. Now, one way to determine very quickly if just some arbitrary graph is a function, okay, by the graph, is say you have just some general function x and y. And the key here, guys, the three kind of goals of this video. First, to determine if a relationship is a function. Now, you could do that by some words, like I did with the players example. But you also should know how to determine if a relation is a function if I give you a table of values, meaning sets of ordered pairs, or a graph, or even an equation. Right? So in this video, you'll learn how to determine if a relation is a function based on graph, table, and equation. Right? If I have time, we'll see. Okay. First of all, by a graph. If I give you a graph and say it's like this, looks like an absolute value, that is going to be a function because you know for every x value in this curve, in this shape, there's one unique y value. The trick to figure this out is to draw a vertical line anywhere on this figure, anywhere on this actual curve. Draw a vertical line. If the graph just hits one time, then yes, it is going to be a function. Because if it just hits one time, that means for this x value, there's just one y value. For this x value, there's just one y value. Same here, same here, same here. For any x value here, any x value on the domain, there is one unique y value. Now, some y values happen twice, right? Like here, say y is like 4 at this level, right? Well, y is 4 twice, 2 times. Y being 4 twice doesn't break the function rule, okay? If x was 4 twice, then it would, right? Because for every x value, there must be only one y value. So if the figure were actually like this, some strange shape, looks like some oblong home plate, well, no, this would no longer be a function because say here x is 4, right? Well, if here x is 4, well, we have 2 possible y values, there and there, okay? So this breaks the function rule. So the vertical line helps us out because it just can tell us whether or not there is more than one y value at a particular x value. So draw a vertical line all over your graph, and if it hits the curve more than once, then it is not a function. Otherwise, it is a function, okay? So that's how to determine if a graph is a function. And now let's talk about some other representations of relationships between variables. How about a table? So I'll start with an example of a table that would represent a function. Say it's like 3, 4, 5, 6, 7, and y is 0, 1, 1, 3, 2. Right? This is a function. For every x value, for an x value of 3, you know there's just one possible y value. It's 0. If I give you an x of 4, y is going to be 1 and only 1. If x is 5, y is 1 and only 1, right? It's okay that y repeated. That's not a problem. I showed you that on the graph also. Right? This is a function. But if we had another, say another 3 here, or even let's be a little, because the 3, that might throw you off. Let's say it's a 4. This is no longer a function, okay? Because now, if I say x is 4, well, y could be 1 or it could be 3. Okay, there's two possible y values for that one particular x value. If that fails once, it's no longer a function. You could also graph these points and then apply the vertical line test. 3, 0, 4, 1, 5, 1, 4, 3. That's up here, right above the 4, 1, right? And then 7, 2. So here are these 5 points on a graph, and you can see right here where x is 4, the vertical line would hit twice. So again, visually, the function rule fails. This is not a function. Okay? Now, in terms of equations, we'll get into this more in class, but if you have a y value that is squared in the equation, it's not going to be a function. All right, we'll get into this more in class because I want to get into the other pieces, but really focus upon, for this video, know how to determine if a relationship is a function visually by a graph and by a table. Okay? Those are the key pieces for right now. Now, finding function values. Okay, so a function value is really a y value. So you really, if you're finding a function value, you're asked to find y after you're given an x value. All right, so here, let's do this in 3 ways. Find function values. Again, let's do this by a graph and by a table, and also, if we have time, which looks like I will, by an equation. Okay, so determine if a relation is a function. We've gone through the definition. Now finding function values. So let's start with a graph again. Say I gave you this graph, and your function was like that. And we're just doing a first quadrant graph here. I don't know why, I just felt like it. Let's say this point here is like 3, and let's put a point here, and that's going to have a corresponding y value of, let's say, 2, and up here we're at, let's say, 4, and here we're at like 1, even though it looks a little bit off scale. Those are our values. So I'm saying this point here is going to be at is 1, 4. This point here is 3, 2. And this point here is 6, 1. Well, it's not really a point, right? It's an open circle. So that point's not actually there. All right? Okay. So if I said to find a function value, the kinds of problem you'd see on a quiz would be this. You'd say, okay, problem 1. Let's say, determine the value of f of 1. Determine the value of f of 1 is how you'd read this. And what this literally means is find the value of y when x is 1. So on this graph, look at where x is 1. And again, if it's a function, there's just going to be one possible answer, right? Where x is 1, okay, the y value, look up and down on the graph, there it is. The y value is 4. So the answer is 4. That's it. You're done. Find the value of f of 1. It is 4. Because the point 1, 4 is on the graph. Find f of 3. Well, that's going to be 2. Because the point 3, 2 is in the graph, right? If x is 3, y is 2. Now, we could approximate. What if I said, instead of find the exact value of these two, if I said to approximate the value of f of, let's say, 2. Well, if f of 1 is 4, f of 3 in this case is 2. F of 2 would be where this vertical line hits the grid, about there. So you'd want to just have a guess at the y value at that point. It looks like it's a little bit more than 3. It's maybe like 3.1 or 3.2. We use the squiggly lines, a squiggly equal sign, to say it's approximately that. So an approximation for f of 2 would be a little more than 3, it looks like, right? And then last, let's throw in the problem, say, find the value of f of 6. Well, you know what, before we do this, let's talk about domain of this problem, just for kicks. The domain of this function is going to be from 1 to 6, but not including 6, right? So if that happens, if a number is not in your domain, if I said f of 6, if I said f of 0, if I said f of negative 20, whatever, what is the y value? It doesn't exist. There is none. Okay? So if I ask you to find a function value for an x value not on your domain, you're just going to write DNE, or just write out the words, does not exist. Okay? The calculator, you know, if you type in an equation of a function in the calculator, and a function value doesn't exist, it gives you an error message, right? Well, that just means the function value does not exist. Okay? So that's what I expect you to write on a quiz. Because my clock is broken, I'm going to check my, okay, very good. So we've now done function values by the graph. Now let's look at, I think you guys would be okay if I gave you a quick table. It's sort of the same thing as the graph, right? If I said, I'll do this very quickly, but if I said, okay, this table represents some function f, and we have values -2 through 2. And say I said to find in this table the value of f of -1. Well, again, this is asking you what is the y value when x is -1, so the answer is 0. Say I said evaluate f of 1. Well, it would be 7, right? And then 2 more. F of 2 would be -8. And now I'll throw you a curveball here. What if I said find the value of f of 0 plus f of 2? Well, you might have that kind of problem. Find the value of f of 0 plus f of 2. This does not equal f of 0 plus 2. So you wouldn't just find f of 2 and say, okay, the answer is -8. You would find f of 0, and you get 4, and find f of 2, and you get -8, and you add up 4 and -8, you get -4. That's the answer. Okay, if you have this kind of problem, you can do them separately. Or another curveball might be like, find the value of, 3 f of 1. Well, it just means 3 times whatever the value of f of 1 is. 3 times 7 is 21. Right? So those kinds of curveballs might be thrown at you at some point. Okay? And last, let's do finding function values by the equation. Okay? An equation is written a little bit differently. Now I got to hustle here. 12 minutes is a long video. Sorry. So we'll do composition later. Okay? But equations are important. So listen up for another 1 minute or 2 minutes. Usually you had an equation y equals, let's do a quadratic just for kicks, 2x squared minus 3x plus 1. Maybe that was a quadratic equation in the past. This is a quadratic function. Yes, it would pass the vertical line test. It is a function. We now write this like this. F of x or g of x or h of x, whatever. Okay? So this is written with the new notation, with function notation. And we only use this if the equation is in fact a function. So if I said find function values with the equation, I would ask you for, okay, f of 1, say. What you would do is, again, it just means find y when x is 1. So you could graph this and then just find the value of y where x is 1. But faster, we just use the equation. Plug in 1 for x. And all you've got to do now is evaluate this side. You don't touch this f of 1. That's the problem. That just tells you, okay, we're finding y when x is 1. Leave this alone. All you've got to do is now evaluate this expression, carefully using PEMDAS. 1 squared is 1. 1 times 2 is 2. 3 times 1 is 3, but it's being subtracted, plus 1. 2 minus 3 plus 1 is 0. Okay, so f of 1 equals 0. That's your answer. If you're asked to find a function value, like all the previous problems, we have just a numerical answer. Okay, so that is the answer, and again, that's a y value. Right, where x is 1, y is 0. All right? If I said find f of 3, you'd plug in 3 for x and evaluate it. But that's just how to do this by the equation. All right? So just a video on definition of function, how to determine if a relation is a function by the table and by the graph, and finding function values by table, graph, and equation. That's what we just covered, albeit kind of quickly. All right? We'll get into this in more detail in class. Have a good day.